All right. Welcome back. This is section P2, so the sort of prerequisite chapter, the second section. This is all about exponents, which I guess you can exclaim. We did some exponents in P1. We didn't really make a big deal about it, but this section is about digging a lot deeper. I think all we did in the last one was square a few numbers. So that'll happen again, but obviously we're going to dig into higher powers and all of the different sort of algebra implications that start to happen when you're doing different sort of variables to powers and then even sort of trying to combine them. So lots to do, all good stuff. So first things first is just being able to evaluate an exponential expression. So that is just like if you're given a number to a power, just being able to say what that's going to be, what number that's going to be. So just definitionally, right? So exponents mean repeated multiplication. Right, so like 5 raised to the 2, what that really means is 5 multiplied by itself 2 times, right? So 5 squared is 5 times 5 is 25, right? Something like, 4 raised to the 3, what we would call cubed, is 4 times itself 3 times. 4 times 4 times 4, right? That would be 16 times another 4 would get us up to 64. Right, and what you can kind of see happening for us here, if we take something like 2 and raise it to the 5, so that's 2 times 2 times 2 times 2 times 2, right? 5 2s sort of all in a row. And you can kind of start to see, right, it gets a little bit trickier to keep track of these. So every 2 of these would be 4, right? So that's kind of 4 times 4 times another 2. That would be 16 times 2, and so that would be 32. In general, what happens here with the exponents is the numbers get pretty big pretty fast, honestly, right? Something like, even what we would call the number that you're repeating is called the base number, right? And then the exponent of itself tells you how many times it's going to multiply. So even for relatively small base numbers, something 2, 3, 4, 5 kind of stuff, if I start to do something like 5 raised to the 4, right? We just did 5 squared, which is 25. So that's pretty reasonable. But now that 5 to the 4, each of those would be a 25. So then you're talking 25 times 25 is like 625, right? So if you do something as simple as jump the power from 2 to 4 when 5 is your base number, you're going from 25 all the way up to 625, right? You're getting just like really, really big, really, really fast. And that's with a relatively small exponent and a relatively small base number. You could imagine, 100, 200, 300, something, 1,000 is your base number, and then taking exponents, into the double digits, triple digits, right? All that stuff gets really, really big, really, really fast. So this is a pretty powerful operation. It kind of is like, it's like super multiplication, honestly, right? It's multiplication kind of taken to the next level. Something like that you can do for, bigger powers would be powers of 10. Something like 10 to the 6. Every time you multiply by 10, what happens is you're going to get another 0, right? So like 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000. So all of those are a 1 with however many zeros. So 10 to the 6 is going to be 1,000,000 because that's a 1 and 6 zeros. So something like 10 you can raise to pretty high powers and get away with it without having to think too hard. Almost any other number, unless you sort of start to have like a table memorized or something, it's going to get pretty big pretty fast. That's okay. That's just a thing that happens. That's just how it goes. The other thing here that's interesting, you can use negative numbers as your base value, so negative base values, and that's going to show up a couple different ways. We're going to want this sort of with and without parentheses. So let me do just like a quick comparison here. Let's take something like -2 and like raise it to the 4. So let's think about what this means, right? So this is kind of a -2 in parentheses raised to the 4. I think in general, this is going to do what people expect when they see this, which is if you have a negative raised to a power, I think what your brain is going to tell you is, right, the number repeats, but the negative also repeats. And so what happens is you have, right, rather than just 2 times 2 times 2 times 2, you get a -2 times a -2 times a -2 times a -2. And so what happens here is you have sequences of negatives that are sort of multiplied together. Every 2 negatives, right, every sort of pair of negatives you have are going to multiply together and give you a positive. So these first 2 would multiply together and get us a +4, and then we would have, right, 2 more, and that would multiply to another +4. So this essentially becomes a +4 times a +4, and the result here is a +16. Right? So if you have this value and it's in parentheses and you're raising it to a power, you're going to repeat the negatives, and what'll happen in this case, because we had 4 negatives, essentially an even exponent, all of the individual negatives kind of pair up and cancel each other out, and you end up with a positive value. And of course 2 to the 4 is 16, and so the number there doesn't really change. If I compare that to -2 and I cube it, so what's different here is I still have -2 times -2 times -2, right? But what's changed is I've got 3 negatives. So the first 2 would multiply to +4, but that third one doesn't have anything to pair with. So I get a +4 times a -2, and so what happens here is I get 8, but now the result is negative. So the odd power, because you have, right, sort of pairs of negatives canceling out, if you end up with an odd exponent, that means you're going to sort of pair up and have one left over, one of the negatives left over all the time, right? So that means your result there, right, is still 2 cubed is 8. That's always true, but because it's a negative and it's cubed, it's going to come out as -8. So I think that's pretty intuitive. I want to say most students I've had kind of expect that to happen and kind of calculate accordingly. What's a little bit less intuitive is what's going to happen if I take away the parentheses. And so here we get really into the nitty-gritty of a sort of order of operations kind of philosophical question almost, right? So what does this mean? So the exponent here is attached to the 2, and it's technically not attached to the negative. So what this really means is like the negative version of 2 raised to the 4. That's not how it's written, but that's really what it means. This is really just like the negative of 2 times 2 times 2 times 2. So it's 4 positive 2's all multiplied together and 1 negative sign in front. So it doesn't really matter here that the exponent is even, right? That we have 4 of them. Your kind of intuition is going to say 4 of those negatives means they're going to cancel and end up with a positive. And the fact here is that's just not what's going to happen. Without the parentheses around here to kind of group the negative under the exponent. So this is the negative version of 2 raised to the 4. So 2 to the 4 is still 16. In this case, a +16, and the 1 negative out in front stays there. So the result that I get is, in this case, a -16, right? So compare those 2, right? And we're getting sort of positive and negative versions of the same answer. It's a little tricky. You need to kind of slow down a little bit there and really kind of take stock of whether you have a negative in this case under your parentheses or not. The other comparison here, what would this look like if the power was odd? And the answer here is, well, this one actually is a little bit tough to really tell the difference, because this one is also going to end up as a negative, but that's kind of what we would have expected from the -2 quantity cubed anyway. So the answers for an odd power are going to match, which in some sense maybe makes it even all that much more confusing about why there's a difference here. So the idea is this would be the negative version of 2 cubed. So in this case, a negative, right? And then 2 times 2 times 2. So that's 8 with a negative in front. So that would be -8. So now those two compare to each other, they actually end up in the same spot. What this means, I guess, in some sense, is in 3 out of these 4 instances, the answer you end up with is a negative. It sort of gets to be negative in some sense for different reasons in each of those. The one instance where you're doing an exponent on a negative number and getting a positive is if it's in parentheses and it's raised to an even power. So that's all stuff to kind of watch for and be wary. I want to say, for the most part, just raising positives to positive powers is pretty straightforward. It's just a matter of actually kind of crunching the numbers if they get big. The negatives, you really have to watch the details on. So be extra careful when you're doing those. The numbers don't get any bigger, but you do have to watch the signs and sort of be comfortable with how you're ending up with these different answers. We'll see some more of these negatives mixed into sort of the rest of our examples as we go. But that's where I want to pause this first video, and then we'll sort of pick up with some more rules in video number 2.